Hi everyone, welcome to Amazing Weapons, the channel where we explore the history and features of some of the most amazing weapons in the world. In this video, we're going to take a look at the F-16 Fighting Falcon, a versatile and cost-effective fighter jet that has been in service for over 40 years. The F-16 is a single-engine, highly maneuverable, supersonic multi-role tactical fighter aircraft that can perform air-to-air and air-to-ground missions in any weather conditions. It was designed by General Dynamics, which is now part of Lockheed Martin, and ordered by the United States Air Force in 1972. The F-16 has been used by many countries around the world and has seen action in several conflicts, such as the Gulf War, the Balkans, Afghanistan, Iraq, Libya, and Syria. In this video, we're going to provide an overview of the F-16's design, development, performance, and combat record. We're going to use information from the current webpage and Britannica as our main sources. So buckle up and get ready for an amazing ride with the F-16 Fighting Falcon. The F-16 was born out of a radical idea in the early 1970s by a small but vocal group of engineers and defense analysts known as the Lightweight Fighter Mafia. They believed that the U.S. Air Force needed a new type of fighter that was smaller, lighter, and more agile than the existing fighters like the F-15 Eagle and the F-4 Phantom II. They argued that such a fighter would have better performance and survivability in air combat against Soviet aircraft like the MiG-21 Fishbed and the MiG-23 Flagger. They also wanted to make the fighter cheaper and simpler to build and maintain than its predecessors. To prove their concept, they initiated a secret project called the Advanced Day Fighter, which later became the Lightweight Fighter Program. The LWF program invited several companies to submit proposals for a new fighter that would meet certain specifications, such as a weight of less than 9,100 kilograms, a thrust-to-weight ratio greater than 1, and a speed of Mach 1.6 at altitude. The program also required the use of a fly-by-wire system, which is an electronic system that replaces the mechanical linkages between the pilot's controls and the flight control surfaces. The fly-by-wire system allows the pilot to fly the aircraft more easily and precisely, and also enables the aircraft to be designed with relaxed static stability, which means that it is intentionally made slightly unstable to reduce drag and improve maneuverability. Out of 5 companies that responded to the LWF program, 2 were selected to build prototypes for testing: General Dynamics with its Model 401, later designated YF-16, and Northrop with its P600, later designated YF-17. The 2 prototypes competed in a fly-off in 1974, which demonstrated their superior performance over existing fighters. The YF-16 was chosen as the winner of the competition in 1975, mainly because of its lower operating costs, greater range, and better maneuverability at supersonic speeds. The YF-16 also had an advantage over the YF-17 in that it used the same engine as the F-15, the Pratt & Whitney F100, which would reduce costs and increase commonality. The YF-17 was later developed into the FA-18 Hornet for the U.S. Navy. The F-16's design incorporates many innovative features that make it a unique and formidable fighter. Some of these features are: a cropped delta wing with leading edge extensions. The wing has a sweep angle of 40 degrees at the leading edge and a straight trailing edge. The wing has a variable camber airfoil that can change its shape by using flaperons, combined flaps and ailerons on both edges. The wing also has large blended winglets at the tips that improve lift and reduce drag. The legs are triangular extensions that run from the wing root to a point forward on the fuselage. They generate strong vortices over the wing at high angles of attack, which increase lift and delay stall. The legs also enhance roll control and directional stability. A fly-by-wire system with relaxed static stability. The FBW system uses electrical signals to transmit commands from the pilot's controls to 4 redundant hydraulic actuators that move the flight control surfaces. The system also has a digital flight control computer that monitors the aircraft's attitude and flight envelope, and adjusts the control surfaces accordingly to prevent loss of control or overstressing. The Falcon also incorporates limiters that restrict movement in each axis based on speed, AOA, and G-force. The RSS design means that the aircraft is slightly unstable in pitch axis when flying at subsonic speeds, which reduces drag and increases maneuverability. The fly-by-wire system compensates for the instability and makes the aircraft easier to fly. A frameless bubble canopy that provides 360-degree visibility. The canopy is made of a single piece of polycarbonate plastic that is resistant to bird strikes. The canopy has no forward bow frame that would obstruct the pilot's forward vision. The canopy is jettisoned before the ejection seat is fired, as the seat lacks canopy breakers. A side-mounted control stick that eases control while maneuvering. The stick is mounted on the right side of the cockpit console, instead of the traditional center position. The stick is pressure sensitive and requires only small movements to input commands. The stick also has several switches and buttons that control various functions, such as weapons, radar, and communications. This arrangement allows the pilot to operate the aircraft with one hand on the stick and one hand on the throttle, without having to reach for other controls. This is known as hands-on throttle and stick concept, which improves situational awareness and reduces pilot workload. A reclined ejection seat that reduces G-force effects on the pilot. The seat is tilted back at an angle of 30 degrees from vertical. The reclined seat allows taller pilots to fit in the cockpit and also increases the pilot's tolerance to high G-forces by aligning the spine with the G-vector. However, the reclined seat also causes some discomfort and neck strain for some pilots, especially during long flights. The F-16 is much smaller and lighter than its predecessors and contemporaries. It has a length of 15.06 meters, a wingspan of 9.96 meters, and a height of 4.88 meters. It has an empty weight of 8,570 kilograms, a loaded weight of 12,020 kilograms, and a maximum takeoff weight of 19,200 kilograms. In comparison, the F-15 has a length of 19.43 meters, a wingspan of 13.05 meters, and a height of 5.63 meters. It has an empty weight of 12,700 kilograms, a loaded weight of 20,200 kilograms, and a maximum takeoff weight of 30,800 kilograms. The MiG-23 has a length of 16.7 meters, a wingspan of 13.9 meters with wings spread and 7.2 meters with wings swept, and a height of 4.7 meters. It has an empty weight of 10,000 kilograms, a loaded weight of 15,500 kilograms, and a maximum takeoff weight of 19,000 kilograms. The F-16's small size and light weight give it several advantages over other fighters. It has a lower radar cross-section than most fighters, making it harder to detect by enemy radars. It also has a lower infrared signature than most fighters, reducing its vulnerability to heat-seeking missiles. It has a higher thrust-to-weight ratio than most fighters, giving it more power to climb and accelerate. It has a lower wing loading than most fighters, giving it more lift and agility. It also has lower operating costs than most fighters, making it more affordable and maintainable. The F-16's development was not a smooth and easy process. It faced many challenges and obstacles along the way, but it also achieved many breakthroughs and improvements. Let's take a look at some of the main phases of the F-16's development and how they shaped the fighter we know today. The F-16's origin can be traced back to the early 1970s, when a group of engineers and analysts known as the Lightweight Fighter Mafia proposed a new concept for a small, agile, and inexpensive fighter that could outperform the heavy and complex fighters of the time, such as the F-15 Eagle and the F-4 Phantom II. They initiated a secret project called the Advanced Day Fighter, which later became the Lightweight Fighter Program. The program invited several companies to submit proposals for a new fighter that would meet certain specifications, such as a weight of less than 9,100 kilograms, a thrust-to-weight ratio greater than 1, and a fly-by-wire system. Out of 5 companies that responded, 2 were selected to build prototypes for testing. General Dynamics with its Model 401, later designated YF-16, and Northrop with its P-600, later designated YF-17. The 2 prototypes competed in a fly-off in 1974, which demonstrated their superior performance over existing fighters. The YF-16 was chosen as the winner of the competition in 1975, mainly because of its lower operating costs, greater range, and better maneuverability at supersonic speeds. The YF-16 design was altered for the production F-16. The fuselage was lengthened by 0.269 meter, a larger nose radome was fitted for the AN/PG-66 radar. Wing area was increased from 26 square meter to 28 square meter. The tail fin height was decreased, the ventral fins were enlarged, 2 more storage stations were added, and a single door replaced the original nosewheel double doors. The F-16's weight was increased by 25% over the YF-16 by these modifications. The F-16 entered service with the U.S. Air Force in 1980 and soon became one of its most important fighters. However, it also encountered some problems during its early years. One of them was the engine issue. The initial engine selected for the F-16 was the Pratt & Whitney F100PW200, a modified version of the F-15's engine. However, during testing, the engine was found to be prone to compressor stalls and rollbacks, which caused sudden loss of thrust. This resulted in several accidents and fatalities and forced the Air Force to restrict the F-16's flight envelope until the problem was resolved. The engine issue also led to the alternate fighter engine program, which allowed General Electric to enter the F-16 market with its F110 engine. The F110 offered more thrust and reliability than the F100 and became a popular choice for many F-16 operators. Another problem faced by the F-16 was its aerodynamic instability. The F-16 was designed to be slightly unstable in pitch axis to reduce drag and improve maneuverability. However, this also made it susceptible to departures from controlled flight at high angles of attack or low speeds. To prevent this, the F-16 had a fly-by-wire system that automatically adjusted the control surfaces to maintain stability and prevent stalls. However, flight testing revealed that under certain conditions, such as multiple limiters being exceeded or electrostatic discharge affecting the electronics, the fly-by-wire system could fail or malfunction, resulting in loss of control or overstressing of the airframe. Several modifications were made to improve the fly-by-wire system's reliability and performance, such as adding limiters based on speed, angle of attack, and G-force, increasing redundancy, upgrading software, and adding manual override switches. The F-16 also underwent several upgrades and enhancements over time to keep up with changing requirements and threats. One of them was the Multinational Staged Improvement Program, which was conducted in the 1980s and 1990s to evolve the F-16's capabilities in 3 stages. The MASIP introduced new features such as increased fuel capacity, avionics upgrades, radar enhancements, and weapons integration. Some of the major changes included MSIP-1. This stage involved upgrading existing Block 15 aircraft with operational capability upgrade kits that added new features such as an improved engine, F100PW220, an enhanced electronic warfare suite, ANA-LQ131, compatibility with Lantern pods for night vision and precision strike capabilities, and integration of new weapons such as IM-120A MRIAM missiles. MSIP-2. This stage involved producing new aircraft with Block 4042 and Block 5052 configurations that incorporated the improvements of MSIP-1, as well as new features such as a color cockpit display, a modular mission computer, a data transfer unit, an improved radar, ANA-PG-68, and integration of new weapons such as GM-88 HARM missiles. MSIP-3. This stage involved upgrading existing Block 5052 aircraft with common configuration implementation program kits that added new features such as a helmet-mounted queuing system, a color-moving map display, an improved radar, ANA-PG-68, and integration of new weapons such as IM-9X Sidewinder missiles and CBU-103-105 WCMD bombs. The F-16 also received various block upgrades that introduced new variants and capabilities. Some of the notable ones included Block 60. This variant was developed for the United Arab Emirates and featured a new engine, F110GE132, a new radar, ANA-PG-80, a conformal fuel tank, an internal FLIR system, and advanced avionics and weapons. Block 7072. This variant was developed for export customers and featured a new engine, F100PW229 or F110GE129, a new radar, ANA-PG-83, an advanced cockpit display, an automatic ground collision avoidance system, and improved durability and survivability. F-16V. This variant was developed as an upgrade package for existing F-16s and featured a new radar, ANA-PG-83, a new mission computer, a new cockpit display, an improved electronic warfare suite, and enhanced capabilities for air-to-air and air-to-ground missions. The F-16's development has been a long and complex journey, but it has also been a successful and rewarding one. The F-16 has proven itself to be one of the most versatile and effective fighters in the world, serving in many roles and missions for many countries. The F-16 has also been constantly improved and upgraded to meet new challenges and threats, ensuring its relevance and competitiveness for years to come. The F-16 is a highly capable fighter aircraft that can perform a variety of missions in different scenarios. It has impressive performance characteristics, such as its speed, maneuverability, range, payload, and thrust-to-weight ratio. Let's see how the F-16's design features contribute to its performance advantages and how it compares with other modern fighters. One of the most important factors that affect the F-16's performance is its wing design. The F-16 has a cropped delta wing with leading edge extensions, or strakes, that generate strong vortices over the wing at high angles of attack. These vortices increase the lift and delay the stall, allowing the F-16 to fly at higher angles of attack than conventional fighters. The wing also has a variable camber airfoil that can change its shape by using flaperons on both edges. This gives the F-16 more control and agility in different flight regimes. The wing also has large blended winglets at the tips that improve lift and reduce drag. The F-16's wing has a low aspect ratio, which means it is short and wide. This reduces the weight and structural complexity of the wing and also increases the roll rate and directional stability of the aircraft. Another key feature that enhances the F-16's performance is its fly-by-wire system with relaxed static stability. The fly-by-wire system uses electrical signals to transmit commands from the pilot's controls to the flight control surfaces. The system also has a digital flight control computer that monitors the aircraft's attitude and flight envelope and adjusts the control surfaces accordingly to prevent loss of control or overstressing. The relaxed static stability means that the aircraft is slightly unstable in pitch axis when flying at subsonic speeds, which reduces drag and increases maneuverability. The fly-by-wire system compensates for the instability and makes the aircraft easier to fly. The F-16 also has a powerful engine that provides enough thrust to overcome drag and achieve high speeds and altitudes. The F-16's engine is either a Pratt & Whitney F100 or a General Electric F110 turbofan, depending on the variant. Both engines have an afterburner that injects fuel into the exhaust stream to increase thrust for short periods of time. The F-16's engine also has a digital electronic engine control unit that improves reliability and reduces stall occurrence. The F-16's engine can produce more thrust than the weight of the aircraft, giving it a thrust-to-weight ratio greater than 1. This means that the F-16 can accelerate vertically and perform impressive maneuvers such as the Cobra and the Culbet. The F-16's performance can be measured by various parameters, such as its speed, maneuverability, range, payload, and thrust-to-weight ratio. Here are some of the values for these parameters for different variants of the F-16. Speed. The maximum speed of the F-16 is Mach 2.05 at high altitude and Mach 1.2 at sea level. The cruising speed is Mach 0.8 at 12,000 meters. The stall speed is 220 km per hour with landing gear down. Maneuverability. The maximum G-force that the F-16 can withstand is 9 grams at any speed up to Mach 0.9. The minimum radius of turn is 430 meters at sea level and Mach 0.8. The maximum rate of roll is 240 degrees per second at Mach 0.8. Range. The combat radius of the F-16 is about 630 kilometers on a high-low-high mission with 6 450 kilograms bombs. The ferry range is about 4,220 kilometers with drop tanks. Payload. The maximum takeoff weight of the F-16 is about 19,200 kilograms. The empty weight is about 8,570 kilograms. The internal fuel capacity is about 3,175 kilograms. The external fuel capacity is about 4,500 kilograms with 3 drop tanks. The maximum weapon load is about 7,700 kilograms on 9 hardpoints. Thrust-to-weight ratio. The thrust-to-weight ratio of the F-16 depends on the engine type and variant. For example, the Block 5052 with an F110 GE 1-9 engine has a thrust-to-weight ratio of about 1.095 at full load and 1.25 at half load. How does the F-16 compare with other modern fighters? Let's take 2 examples, the F/A-18 Hornet and the Rafale. The F/A-18 Hornet is a twin-engine, multi-role fighter aircraft developed by McDonnell Douglas and Boeing for the U.S. Navy and Marine Corps. It is also used by several other countries such as Australia, Canada, Finland, Kuwait, Malaysia, Spain, and Switzerland. The Fa-18 has a maximum speed of Mach 1.8 at high altitude and Mach 1.2 at sea level. It has a combat radius of about 610 kilometers on a high-low-high mission with 4 900 kilograms bombs. It has a maximum takeoff weight of about 25,400 kilograms and a maximum weapon load of about 6,200 kilograms on 11 hardpoints. It has a thrust-to-weight ratio of about 0.93 at full load and 1.13 at half load. The Rafale is a twin-engine, multi-role fighter aircraft developed by Dassault Aviation for the French Air Force and Navy. It is also used by Egypt, Greece, India, and Qatar. The Rafale has a maximum speed of Mach 1.8 at high altitude and Mach 1.1 at sea level. It has a combat radius of about 685 kilometers on a high-low-high mission with 6 to 150 kilograms bombs. It has a maximum takeoff weight of about 24,500 kilograms and a maximum weapon load of about 9,100 kilograms on 14 hardpoints. It has a thrust-to-weight ratio of about 0.988 at full load and 1.13 at half load. As we can see, the F-16 has some advantages over the Fa-18 and the Rafale in terms of speed, maneuverability, range, payload, and thrust-to-weight ratio. However, these parameters are not the only factors that determine the effectiveness of a fighter aircraft in combat. Other factors such as avionics, sensors, weapons, stealth, tactics, training, and support also play important roles in the outcome of an air battle. The F-16 has a remarkable combat record in various conflicts and operations around the world. It has proven itself to be a versatile and effective fighter aircraft, capable of engaging both air and ground targets in different scenarios. In this part of the video, we will highlight some of the notable achievements and incidents involving the F-16, such as Operation Opera. This was a daring raid on Iraq's Asyrik nuclear reactor on June 7, 1981. Carried out by 8 Israeli F-16s escorted by 6 F-15s. The mission was to prevent Iraq from developing nuclear weapons that could threaten Israel and the region. The F-16s flew at low altitude to avoid detection and delivered 900 kilograms bombs that destroyed the reactor core. The operation was a success, with no losses or damage to the Israeli aircraft. Operation Desert Storm. This was the largest deployment of F-16s in history, with over 200 aircraft from the U.S. Air Force, Air National Guard, and several allied countries participating in the 1991 Gulf War against Iraq. The F-16s performed various roles, such as air superiority, suppression of enemy air defenses, interdiction, close air support, and reconnaissance. The F-16s flew over 13,000 sorties and achieved 35 confirmed air-to-air kills, mostly with IM-9 Sidewinder missiles. They also destroyed hundreds of enemy vehicles, tanks, artillery pieces, bunkers, bridges, and other targets with a variety of bombs and missiles. The F-16s suffered 14 losses, mostly due to anti-aircraft fire and surface-to-air missiles. Operation Enduring Freedom. This was the U.S.-led intervention in Afghanistan following the 9/11 attacks in 2001. The F-16s played a key role in supporting the ground forces and striking Taliban and Al-Qaeda targets. Also made history by being the first to use Joint Direct Attack munition bombs, which are guided by GPS signals and can hit targets with high accuracy in any weather conditions. The F-16s dropped over 10,000 Joint Direct Attack munitions during the operation, accounting for more than half of the total number of Joint Direct Attack munitions used by all U.S. aircraft. Operation Odyssey Dawn. This was the U.S.-led intervention in Libya in 2011 to protect civilians from the regime of Muammar Gaddafi. The F-16s participated in enforcing a no-fly zone over Libya and conducting airstrikes against Gaddafi's forces. The F-16s also performed SEAD missions to suppress Libya's air defenses, which included Soviet-made SAMs and anti-aircraft guns. The F-16s used a GM-88 high-speed anti-radiation missiles to destroy radar sites and launchers that posed a threat to coalition aircraft. The F-16 has also been involved in many air-to-air and air-to-ground victories claimed by F-16 pilots from different countries, such as Israel. The Israeli Air Force has used the F-16 extensively in its conflicts with its neighbors, especially Syria and Lebanon. The F-16 has achieved over 100 confirmed air-to-air kills for Israel, making it the most successful fighter in Israeli history. Some of the notable kills include a Syrian Mi-8 helicopter shot down with cannon fire in 1981, an Iraqi nuclear reactor bombed in Operation Opera in 1981, 4 Syrian MiG-23 shot down AIM-9 Sidewinder missiles in one day during the 1980 Lebanon War. An Iranian-made UAV shot down with Python 5 missile in 2006. And a Syrian MiG-23 shot down with Python 4 missile in 2014, Pakistan. The Pakistan Air Force has used the F-16 in its conflicts with India and Afghanistan, as well as against domestic insurgents. The F-16 has achieved at least 10 confirmed air-to-air kills for Pakistan, mostly against Soviet and Afghan aircraft during the Soviet-Afghan War. Turkey. The Turkish Air Force has used the F-16 in its conflicts with Greece, Syria, Iraq, and Kurdish rebels. The F-16 has achieved at least 6 confirmed air-to-air kills for Turkey, mostly against Greek and Syrian aircraft. Some of the notable kills include a Greek Mirage F-1 shot down with AIM-9 Sidewinder missile in 1992. Greece. The Hellenic Air Force has used the F-16 in its conflicts with Turkey and in NATO operations. The F-16 has achieved at least 2 confirmed air-to-air kills for Greece, both against Turkish aircraft. The notable kills include a Turkish F-16 shot down with our 550 Magic II missile in 1996, a Turkish RF-4 reconnaissance aircraft shot down with our 550 Magic II missile in 2012. These are just some of the examples of the F-16's combat record, which shows its versatility and effectiveness as a fighter aircraft. The F-16 has been used by many countries around the world and has seen action in several conflicts, such as the Gulf War, the Balkans, Afghanistan, Iraq, Libya, and Syria. The F-16 has also been constantly improved and upgraded to meet new challenges and threats, ensuring its relevance and competitiveness for years to come. The F-16 is a remarkable fighter aircraft that has proven its versatility and effectiveness in many battles and challenges. It has also been constantly improved and upgraded to meet new requirements and threats, ensuring its relevance and competitiveness for years to come. The F-16 is still in service with the U.S. Air Force and many other countries, and it is expected to remain operational until at least 2048. The F-16 is also being modernized with new radars, avionics, weapons, and systems to enhance its capabilities and extend its service life. The F-16 is also being exported to new customers, such as Bahrain, Slovakia, Bulgaria, Morocco, and Taiwan. The F-16 Fighting Falcon is truly an amazing weapon that has made a significant impact on the history of aviation and warfare. It is a testament to the ingenuity and dedication of its designers, engineers, pilots, and crews who have made it one of the most successful and widely used fighter jets in history. Thank you for watching this video. If you enjoyed it, please give it a thumbs up and subscribe to our channel for more videos about amazing weapons. See you next time!